Good day, I'm Dr. Ting, and in this video clip, we're going to cover Module 4.1, Introduction to Machine Learning. This will be the contents that we're going to cover. First, let's understand what is machine learning. According to Hubert Alexander Simon, learning is any process by which a system improves performance from experience. So machine learning is concerned with computer programs that automatically improve their performance through experience. Now, machine learning is to develop systems that can automatically adapt and customize themselves to individual users' needs. It can personalize, for example, the news that you're going to receive, the mail filter, whether you want to receive this email or you don't want to receive certain email, and judge them as a junk mail. And discover new knowledge from large databases, which will be your big data, and this is under data mining field. For example, we can carry out market basket analysis by looking at the transaction that we are going to collect every day. Now, from this transaction, there is one very popular example of market basket analysis, which is called diapers and beer. People will not be putting diapers and beer together, but according to a data mining market basket analysis, they found out that those fathers that go and purchase these diapers after a day of work, they will normally buy a beer together as well. So after finding out this pattern from a big data set, they put these diapers and beers together in order to ease the customer and encourage the customer who buy diapers to get beer together. So by putting these two together, they found out that they increase the transaction or they increase the sales. The next, machine learning has the ability to mimic human and replace certain monotonous tasks which require some intelligence. For example, recognizing the handwritten characters. It also develops systems that are too difficult or expensive to construct manually because they require specific detailed skills or knowledge tuned to a specific task or knowledge engineering bottleneck. And they can solve this by using machine learning. Why now machine learning? Because we have a lot of available data or big data, especially with the advancement of the internet and also the internet of things and internet of everything. Increasing computational power. This is happening today. As you can see that the power of the computer is actually increasing exponentially as well. And then growing progress in available algorithms and theory developed by researchers. There are many researchers from the industries or from the academic, those who are studying master or PhD, they come up with a lot of algorithm, which is very, very useful. And we got a lot of increasing support from several industries which support the development of machine learning. This is the big data era nowadays. We have plenty of data, or we call it big data, available everywhere with low storage cost. Everyone has several gigabytes for free. For example, cloud computing or the cloud provider, and a hardware more powerful and cheaper than ever before. We also have a lot of devices, a computer fully packed with sensors like GPS, cameras, microphones that collect data anytime, anywhere, every second. And the services that we have nowadays, especially the cloud computing, which offer the online storage with lower cost and also offer infrastructure as a software. For the user application, we have YouTube, Gmail, Facebook, Twitter, and so on. So all these are some of the drivers that cause the machine learning to become so very important nowadays. Okay, let's take a big picture. Where does machine learning actually be located? Artificial intelligence is the big umbrella, and machine learning is a part of artificial intelligence. Other than machine learning, reasoning, natural language processing, planning are under artificial intelligence. And under machine learning, we have big four puzzles here: supervised learning, unsupervised learning, reinforcement learning, and deep learning or neural network. So we'll look into each one of these in the later slides. The first will be the supervised learning under machine learning. It's a machine learning approach that's defined by its use of labeled dataset. Dataset is a set of data in which it will be arranged, like for example in row and columns. Now the columns will be the features, feature, the features, the columns, the features of your data. Now these data sets are designed to train or supervise algorithm into classifying your data or predict certain outcome accurately. And you are going to label the input and output, so the model can measure the accuracy and learn over time. This is what happened. You have the raw data, and from the raw data you have columns and rows, now row by row of records. Then you have to label which feature is the output that you want to predict. Say for example, you have collected from a group of people their sleeping time, their diet, and also their height, their weight. You want to predict whether this person after a period of time will put on weight or actually will lose weight. So based on their diet, their sleeping pattern, their working patterns, their works, their other attributes like the age and so on and so forth. So by putting in all this input, what is the output that we want to predict? The output is the weight of a certain people. So you put in this and label it and say, okay, the rest other than the weight will be the predicted outcome, and the rest will be the input, which might become the factors that will affect the weight, but you don't know which one will affect the weight. So after you have labeled this for a system, then the system will, based on what you have labeled, and construct an algorithm that best predict this weight. So this is called supervised learning with the help of human to label your features. The columns is actually the features. And they are going to learn. The more data you provide to the machine is going to learn and increase its accuracy based on the algorithm that they constructed from the learning, from the experience. So under supervised learning, you can use all these algorithms: neural network, naive Bayes, linear regression, logistic regression, SVM, KNN, random forest. In different data set or different scenario, you will be using different kinds of algorithm from here. It depends on different set of data set. Under certain case study, logistic regression might perform better with higher accuracy as compared to SVM. But when you use another data set for another use case, naive Bayes might become the best among the rest of the algorithm. Let's come to the second category of machine learning, which is unsupervised learning, which use machine learning algorithm to analyze and cluster, means group or categorize, unlabeled data set. So at this time, at this moment, you don't interference, you don't label any of the column, which one is input, which one is output, but you just give the raw data to the machine, and the machine is going to interpret it, come up with the algorithm to group or cluster your the people, group the people or group the objects or categorize them. So these algorithms discover hidden patterns in your data without the need for human intervention. Therefore, they are called unsupervised. Unsupervised learning, you can use clustering algorithm or dimensionality reduction algorithm. The third category of machine learning is called reinforcement learning. It's a machine learning training method based on rewarding the desired behavior but punishing the undesired one. A reinforcement learning agent is able to perceive and interpret this environment, the data set, take action, and learn through trial and error. So you give him the raw data set, and this agent is going to base on the environment, the data set, and reward the correct behavior, but punish the undesired one. Developer devise a method of rewarding desired behavior and punishing negative behavior, and assign positive value to the desired action to encourage the agent itself, and then negative value, it will give negative value to undesired behaviors. So this program this program the agent or train the agent to look for a long-term and maximum overall reward, because you want rewards, right? So agent also want rewards, and therefore you will force or train the agent to achieve optimal solution by achieving the correct or the desired behaviors. And the last category will be the deep learning. It's a subfield of machine learning concerned with algorithm inspired by the structure of and function of a human brain, which is called artificial neural network, a large neural network acting just like brain. It exists, the deep learning exists due to the huge amount of data that can be accessed nowadays. It can do better performance with huge data sets. This is a machine learning technique that teach the computer to do what comes naturally to human, learn by example. It's just like your human brain, right? You learn from the examples, you learn from the experiences. So deep learning is the key technology behind driverless car, enabling them to recognize the stop sign and then distinguish that there's a pedestrian. So this and then the voice recognition, voice control, like for example your smartphone, tablet, TVs, your hands-free speaker, all these are using deep learning. In deep learning, computer model learns to perform classification tasks directly from the input, which are the text, the images, the sound. So they need to learn what does it mean by all these images, text, and sound. Deep learning model can achieve the accuracy, very high accuracy, and sometimes exceed the human level performance. So these models are trained by using large set of label data and neural network architecture that contain many layers. There are many layers. Okay, but before, if you're not using deep learning, you have only simple layer. But deep learning, you have multiple layers. All the learning algorithm, you need the performance is it becomes static even if you increase the amount of data. But for deep learning, as you increase the amount of data, it will be learning more and more. It will be more and more accurate, and performance will increase. Let's take a look at the process of the deep learning. First is to understand the problem and whether the deep learning is a good fit in this situation. Then you have to identify relevant data sets and prepare them for analysis. Then choose the type of data learning algorithm to use. Then train the algorithm on the large amount of labeled data. So you are using labeled data as well. And then test the model's performance against unlabeled data. So you have two sets of data. One is for training and another set is for testing. Type of machine learning algorithm. For supervised learning, we have classification and also regression. For unsupervised learning, we have dimensional reduction and clustering. And these are some examples of use cases. And for reinforcement learning, we have gaming, finance sector, manufacturing, inventory management, robot navigation. Okay, let's take a look at machine learning versus deep learning. Machine learning, you have input of your data set. Okay, both you give them the input, and the machine learning is going to extract feature. Features means the columns of all the value of each set of your data, like for example age, experience, your height, your weight, your diet, your exercises time, hours. All these are features extraction, and then classify them, and the output of your or the prediction, the output or the outcome of your calculation or algorithm. Okay, so the algorithm has a rather simple structure such as linear regression or decision tree. But deep learning, you have the same raw data, input it, then you have feature plus extraction plus classification with multiple layer as compared to classification. Okay, multi-layered artificial neural network, just like your human brain. It is complex and intertwined. The lower need for human intervention and a larger data requirements require much less human intervention in the deep learning. Several applications of deep learning. Python deep learning application, for example. Python is a very popular data analytics in deep learning. Instance, visual translation. Visual translation. You give it an input of the image, and the computer will be able to tell you what is identified from the image. Predicting the future, say for example, if my sales for this month is 20,000, then you will be able to, based on my transaction for past few years or past few months, to predict my next month's sales. Chatbot, online chat, and medical care, self-driving cars, which is very popular nowadays. Colorizing the images for certain purposes. You might need to use this to identify certain images, hidden images in the image. Read lip movements and identify what is the sentence. Photo description. This is also from the image. Deep learning is one of it, and advertisement. These are the steps to solve a machine learning problem. First, you have to gather the data and pre-process the data, because the data set, the raw data sets might not be, sometimes it will be, and a lot of time it is actually very messy. You will need to identify what is missing value, or some of the features are not important. So these are under data pre-processing. Then feature engineering, you have to select which feature is important, and you will have to transform the feature or combine two features into one features, and so on and so forth. Then it will come to the next step, which is algorithm selection and train the model. And lastly, you will have your model to make prediction and evaluate the model whether it is accurate. So now let's take a look at each of these steps. Under the data gathering, might depend on human work, because say for example in the survey you might want to collect data from the human being, so this will depend on human work to collect it. Manual labeling for supervised learning involve domain knowledge, may even the experts to actually construct the questionnaire, for example, identify the features required that need to be included in your questionnaire. May come from free or thorough, for example, machine translation, automatically translated from your mobile phone's data. And then the more the better for the data. Of course, the more the large amount of data that you have, it will be better. It will, say for example, deep learning neural network, it is very useful for it to train it. The quantity and quality of data detect the model accuracy. So you have large amount of data, at the same time it must have high quality. However, most of the time, your data does not, the raw data does not actually has higher quality. So what you need to do is to pre-process the data after you have collected it. So what's wrong with the data? For example, you might have missing value. People forgot to fill in certain fields, or you have outliers. These are the example of outliers. Like for example, everybody fall under this range, but suddenly there are 3 or 4 people that answer outside of this range. So you might want to remove the outliers cases. Bad encoding for text, especially when you translate the text, you might have bad encoding, you might have wrongly labeled examples, and from the survey as well, you might have biased data, and therefore you might need to fix and remove some of the data. This is also the outlier example. Now we come to feature engineering. What is a feature? A feature is an individual measurable property of a phenomenon being observed. Say for example, a set of features that you collect from a group of people. What is your job? What is your working hours? What is your salary? And then is this your first company? So all these are the features, a set of features. To classify spam email, features that you can use, number of words that have been like this, in this works that is not recognized, normal words, language of the email, English or Spanish, number of emoji. If there are more emojis, then perhaps you should group it under the spam email. So in order to classify certain if you want to classify in different use cases, you might want to consider which set of features that you want to consider in order to predict whether they belong to this group of email or this group of people, or they belong to another group of people. It depends on the features that you select. Extract more information from existing data, not adding new data per se. Making it more useful with good features, most algorithms can learn faster. Feature engineering is very important. You might have 20, 30 features, but not all features are useful in training your algorithm. So you must select those useful features. There are actually several ways to identify whether the features is useful or not. One of it is by using the correlation to find out whether this feature is closely related with the output that you want to predict. If it is highly and significantly correlated, then you might want to select this feature. It can be an art, requires thought and knowledge of the data from the experts as well. You can get input from the expert whether these are the features that are closely related with the output that you want to predict. Two steps of feature engineering: variable transformation. For example, you might want to transform your dates into weekdays or normalize it, because sometimes when you collect the date, it will be in a full format. The year, the day, the month, the year, the time, with hour, minute, second. So you might not need so much information, and therefore you might need to do this transformation to extract certain value from your feature. Feature creation, engram for text, if word is capitalized to detect the names, for example, you will need to do the transformation as well. Or to create from one feature, you create another new feature by transforming the value. The next step will be the algorithm selection and training. So we have we have actually four groups of it: the supervised, unsupervised, deep learning, and reinforcement. We have also this tool, like for example, RapidMiner, that you can actually put in just dumping the data set, and you choose all of this algorithm and try to run all of this algorithm on the data set and look at the output and look at the accuracy, then select which one that you want to use. Like for example, if you are going for supervised, then you just select all of this, and the result will tell you the accuracy level of each one of this algorithm. Then after you have decided, okay, maybe decision tree in this case has the highest accuracy, then the next thing is actually to train it, to improve it, to make some improvement, okay, by selecting, evaluating the features. When you remove certain features, perhaps it will increase the accuracy. This is called hyperparameter tuning. You might want to increase, you might want to adjust on the features, you might want to combine certain features, and the goal of training is to make the correct prediction as often as possible and increase the accuracy of your algorithm. And the last step in your machine learning will be making predictions. So after you have trained your algorithm, now you can make use of this trend model in your prediction phase, in which you are going to give it another set of input, and then try your model, your machine learning model, and look at the output, whether it can answer or it can predict accurately. So this is a summary of what we covered just now. Machine learning is the intelligent use of your data to answer your question, and this is enabled by an exponential increase of your computer power, data storage, big data. We have three big types of problems. Supervised, we can solve the problem. Three big types of problem solving. It can be supervised learning, unsupervised reinforcement, and the other subfield will be the deep learning. Then 5 steps to every machine learning solution. You need to gather your data, prepare your data, and you need to conduct the feature engineering. then algorithm selection and train your algorithm, and lastly make prediction, means use your algorithm to test whether the prediction is accurate. This is the cycle of your machine learning. First, you prepare the data, train your model, then select the parameter features in order to further train it. Okay, then transfer the learning into the model. Then the model or the algorithm that you built will be used in another testing for model verification. Once it is confirmed, you can deploy it into the system. Then try to monitor its result, the performance, and then further build it and go back to data preparation. If let's say you want to further increase its accuracy, then you can go through this cycle again. In machine learning, while training data set, we often encounter the problem of overfitting or underfitting of the data set. So in order to overcome the situation, normally we will divide our data set into 3 data sets. The training, which is used to train your algorithm, and after that you will need to use another set of different data set to validate your algorithm, and another set of data set to test your data set, to test your algorithm. This also means that, let's say if you have a data set with 200,000 records, 200,000 records, big data set, okay, 200,000, then you will need to split your 200,000 record into training set, validation, and test set. You can use a different ratio like 1, 1, 1. So for example, 300,000, okay, to make it easy, 300,000 data set records, then 100,000 will go for training, 100,000 will go for validation, and another 100,000 for testing. This can be done automatically by the tool, the existing tool. They can help you to split it. You just need to mention what is the ratio, perhaps 1:2 or 1:2, so you can actually split out the data set automatically. Again, the machine learning data set, the division of the data set into the above 3 categories, you can put the ratio like 6:2 or 60-20-20%, 60% go for the training, 20% go for the validation, 20% go for the test data set. For training data set, this is used to train your model, which is used to update the weight of the model. And then for validation data set, used to reduce overfitting, to verify that the increase in the accuracy of the training data set is actually increased if we test the model with the data set that is not used in the training. Because if you use the same set of training data set, it might produce biased result. So we split it into 2 different data sets, and after you train it, you are all right with the accuracy, you achieve the accuracy goal, then you test it with another new data set to overcome the overfitting. And then the last data set, which is the test data set, most of the time when we try to make changes to the model based upon the output of the validation set here, then unintentionally we might make the model fit into our validation set as a result. So our model might get overfit on the validation set. And therefore, to overcome this, we have another third data set, which we call as test data set. That is only used to test the final output of the model in order to confirm the accuracy. So, which also means that you go through at least 3 times of training. You train your algorithm initially, and train second time, and you fine-tune the third time. There are many different types of data that you collect. It can be numeric, which is in number. It can be categorical, like for example, true or false. It can be time series. You have a sequence of number collected over the time, a period of time. And then it can be a text format. Now, different types of data is important to be identified, because if let's say you know what you want to predict, then you should design your questionnaire in such a way that you decide the type of data that can be processed by the machine learning. So for example, if you go for interview, then you will be collecting text data. You will need additional pre-processing of your text data into digitalizing it, and also extract the information from the text. So interview might not be the best. What you will need to go through the numerical, maybe categorical or time series data, which is your data pre-processing. Machine learning programming language will have many programming language, like for example, Python, JavaScript, and then RLab, Java, MATLAB, C++, and so on, so forth. Python currently the world's fastest growing language. It's built for readability and ease of use. So Python, if you're interested, you can try with this. And together with this Jupyter, there are many online video clips that teach you about Python for the beginners. So if you're interested in this Python, then you can also join their forum community like Overflow, GitHub. And then recently, Google also came up with the excellent free cloud service known as Google Colab, which you can use to build, train your network in Python from scratch. Okay, this is the Python for computer vision, the library that they provided. And for Java, Java is a general purpose programming language, portable and among the most common language used in the world, not only in data analytics, but also in games, in other basic programming or object-oriented. So this is preferable in the case when we want to have security and fraud detection in our application. All right. For Java, this will be the library that they provide for information. Okay, R language, scripting language, and it's good to handle and visualize data, which plays a key role in machine learning algorithms, if you're interested. Okay, majorly used in academics and also research. And then for MATLAB is easy to use programming language for beginner to experts. Experts also use MATLAB actually. PhD students also use MATLAB in the field of machine learning. Take lesser line of codes compared to other language because other programming language you have to write like plain language. Or although we have the tool to help you, but then MATLAB is much like digitalize it, visualize it, and it's much easier. Okay, these are the platforms for machine learning: IBM Watson, Microsoft Azure, Amazon AI1. Some of them are free, but most of them are not free. You need license. Machine learning platform, Microsoft Azure. As we can see, Microsoft Azure actually provide the cloud computing. Machine learning tool that permit developer to build the model. This is the, they provide the SDK, the software development kits for you to quickly prepare the information, train it, and deploy your machine learning. These are the features. They have an interface, automated program to run the decision tree, deep learning, supervised, unsupervised. And IBM Watson developed for both developer and user with lots of AI tools. So this will be for experts, the trained programmers. This will be the features. They also has this graphical analytics, data analytics, information and prediction must store in the IBM Bluemix because you're using IBM. So it must come together with IBM Bluemix. And definitely this is not free. Amazon offer ready-made and simple available prediction model for the developers, software engineers. If they have no idea about data science, then you can play around with this. This is pay-as-you-go model, so this is not free as well. And this is the Microsoft Azure Machine Learning Algorithm cheat sheet. What do you want to do? It is going to guide you. For example, extract information from text. Then if let's say you're going to do text analytics, say for example you want to collect the social media comments, it will be in text format. Then you will go for text analytics, derive high quality information from text. So this will be what they are going to do. I mean, they provide all these services. Then if you want to predict, like for example, I want to predict my CGPA for the next semester, then you can go for regression. And then if you want to generate a recommendation, what is recommended? If let's say I encounter this issue, then what is the recommendation? So you go for collaborative filtering. And then if you want to discover structure, then the hidden pattern, you can use clustering. If you want to find out unusual occurrence, like for example, a group of students, who are the outliers, then you can go for anomaly detection. If you want to predict between several different categories, I have several features. What will happen if this, if I have this A and B? Can I predict B based on A? Can I predict C based on AB? Then you can use multi-class classification. Predict between two category, you can use two-class classification. And to classify images, then you have image classification. This is a big picture that help you to choose the best machine learning algorithm for your prediction analytic solution. The future of machine learning. Machine learning will be embedded in most of our application, and we can see machine learning actually used in like GPS, in many other applications like driverless cars. Train data as a service will become a prerequisite as well, because data set is very difficult to get a big data set as for researcher. Like for example, if you are not in the industry, you do not have the access to the big data set in the industry, is confidential. So data as a service is another potential service that you can provide to the researcher, to the academician, to the student, in order to use and train your data and also do some experiment on your data. Continuous retraining of the models. Machine learning as a service will grow. Machine learning as a service means the service provider might provide you with the processes or the platform or the services for you to plug in the data, and you just tell them that I want to predict this. Then they will give you the output or the algorithm that, okay, this is the best algorithm that you can actually try to use in order to predict. The maturity of natural language processing. Natural language processing, say for example, while I'm talking and you're recording, so you can actually exactly come up with the caption based on the text, based on the natural language that I am talking, like in English or in Mandarin. We'll be able to identify the text and accurately come up with the caption. This will go under natural language processing. Is machine learning the answer to everything? Well, I'll say we cannot assure that 100% machine learning is the answer to everything, but machine learning is used everywhere. It's exploited, it's researched, and it is embedded in many applications nowadays. With that, that's all for this module, and I will see you again in the next video clip. Thank you for watching.